Good morning, good afternoon, and good evening, everyone. Thank you for joining today's webinar where you'll be able to ask the PTP team any questions you have for them. You can do that by entering your questions into the questions box or the chat box. At this point, I'm going to pass it over to Alan Yu, Director of Product Management. Alan, when you're ready, you can take things from here.
Okay, thank you, Olivia. Hey everyone. Good morning, good afternoon, good evening. So we're gonna talk about the P2P, and we're gonna answer all the questions. So you can start post your questions. Before we do that, we want to we want to have highlight a product for the first 10 minutes. We're gonna cover the 850E. And then, we're going to look at the question you come up, and then we're going to answer question by question. And you can ask question from, all the Cyber 6, the PTP 450, 550, 670, 700, or, to the licensed microwave 820, 850. Any question, we're open here. Okay, so let's start. So 850E is a product we released last year in Q4. Actually, it's nearly the end of the year, so it's kind of like a new product. So we wanna highlight here is this is a 10 gig E-band radio, covers 71 to 86 gigahertz, and we support very high modulation. We support up to 512 QAM. And there is 4 different channel sizes we support. So you can see on the 200 megahertz channel with 124 QAM, we will be able to support 10 gigabits full duplex. And the radio has 40 gig interface built in. The reason is we can support a 2+0 configuration. When we do the adjacent channel or different channel to the combination, we can put one radio as a host, the other radio as the other connect with the other radio, so we can combine the 10 gig throughput to provide a single cable running 20 gig, and that is why we have a SP interface. QSFP interface, we can deliver a single cable with 40 gig. And in addition with that, we also have 5 different SFP 10 gig port available, so people can run with that. In addition, the radio also supports channel bonding. We posted the software 10.5 on the webpage. With 10.5, you can using 850E with 820 licensed microwave to provide a channel bonding running the multiband configuration. So here the interface, I'm going to go through very quickly. We have 6 ports here, and port 1 is the DC input for -48. Port 2 is PoE in with 1 gig copper interface. Port 3 is a 2.5 gig SFP port, and port 4 is a QSFP cage. You can also split this one to 4 single SFP plus interface 10 gig. And port 5 is SFP plus interface 10 gig. And port 6 is for management and ready for hot standby or XPIC we're going to use in the future. It's not supported right now. If you want to do 2+0, you gotta do running adjacent channel or separate channel to do the 2+0. All the mechanical interface are the same, like 820E. So all the mediation devices are shared. Including antennas, the couplers, or the coupler, the XPIC mounting kit. They're all the cross mounting kit. They're all same. So mediation devices are the same. This is how the radio looks like when you do the installation. You have the antenna, you direct mount the antenna, and that's very simple. When you do the 2+0 configuration, basically we have the mediation device here. You can put radio side by side and direct attached with the antenna. One of the things on the 850E is we add a new feature called adaptive coding modulation and bandwidth. So adaptive coding modulation, people is very familiar with. It's a license key. It's part of the capacity license key. There's no, it's always there to enable the ACM. And with ACM, basically you're not changing the channel size. You just change the modulation. when the modulation go down, you gain not only on receive sensitivity improvement, but also you gain on transfer power improvement. So on the both side, you will get a more system margin, the system link budget to get a more margin to sustain. And one of the things we add in the 850E is the bandwidth, adaptive bandwidth as well, which means is basically when we're down to QPSK mode, and if we see we need additional system gain or margin to maintain the link, we will shrink the channel size to half of the size at the first step, and then we're gonna shrink the channel size again to 1/4 of the channel size, stay on BPSK. So with that, it will simply improve our arc sensitivity because the channel size become narrower. We will sacrifice the capacity, but we will provide the improvement on the margin to maintain the link. So the benefit is really, we will further improve the system link availability. And all the data will follow the QoS. High priority data will pass first, and the low priority data will pass later. With the ACMB, you can see now we have more steps for the ACM schema. So the data will be pretty smooth when we have the ACM kick in. The other one we want to highlight here is the multiband support. So multiband support is, the way we implement it is very unique, or it's not a failover. Instead, it's aggregation. So we put a microwave link together with an E-band link together, and we can share the same antenna, or we can using separate antenna. So it really depends on which frequency you're in, and is this a new installation or this is add-on to existing licensed microwave. So in this one, the picture here show a setup shared antenna. Well, we have 1 and 2 foot for both 18 and 23 gigahertz. You can have a multi-band antenna to the this kind of like direct mount setup. Also, in the case you can have a different, existing licensed micro. Could be a licensed micro from Cambium, or it could be a third-party microwave. We can do both. And we're using the 850E as a hosting. So you can see we have 1 gig capacity, 1 gig connection between the microwave and the E-band radio. And then on the 850E, we will do the layer 1 aggregation, combine the data together, and then we will send to the customer's device. In the case of our deployment, as I said, it's not a failover until like some almost all the product in the market. What they do is when the E-band is lost, and then the data will shift to the microwave. In our configuration, what we do is the E-band and the microwave data capacity is always combined. So we can support up to 10 gig capacity with aggregation. So let's see, in the case if my E-band is 7 gig or 6 gig or 2 gig or 1 gig, as long as my E-band ACM is kick in, the capacity go down. The data always aggregated. So I'm not sending data only on E-band. Instead, some data will be sending through E-band, some data will through the microwave. So the combined data is transparent to the customer side. And when the data arrive on the receiver side, because the data come from 2 different paths, we will regroup them together on the receiver end's E-band radio, and then pass to end user data, pass to end user's router. So it's very unique. It's aggregation capacity and transparent layer 1 aggregation using a private protocol, and that is multiband. With that, this is the highlight for today for the 850E. Now let's go back to the audience here. So we have 2 group of product. This is Cyber 6, and this is licensed microwave. And let's see what questions we have. Okay. So the first question I have is, what are the recommendations about install 2 or more P2P in the same mast on 5.8 gigahertz? Well, I guess the question really is about channel separation, kind of like co-located P2P using the 5 gigahertz P2P. So in the 5 gigahertz is a TDD radio. There are several things we recommend. One is we definitely want you enable the assuming we talk about same radio here. Okay, it's not very clear to me. There are different radio, same radio. Assuming this is the same radio, we definitely want to enable the TD synchronization, so you will be able to minimize interference between the radio itself. And the other thing you want to consider is, the channel allocation. And in the we depend on which radio we talk about. Most are on the 670 line. The radio on the DSO mode, the dynamic spectrum optimization. This is basically the radio scan the whole spectrum, and radio always work on the lowest interference channel. So when you have that, the radio will search the channel itself. You kind of like let it go. But if you do have some, say you want to manage this, say you for certain channels you don't want radio to be jump in, then you can block those channels from the UI. You can see I only want a radio scan, from go to channel, say channel 10 and above. You don't want to go to lower frequency. So because there are certain things there, so you can do that. So the thing is, open the TD sync. That's one recommendation. Open the DSO if the radio support DSO. If the radio do not support DSO, like 550E today, it's fixed frequency, 550. So then assign the channel. You do the scan first, and then assign a clean channel. You don't want two-channel radio works on same channel. Generally speaking, we recommend them using at least adjacent channel, or you can put additional channel in between. Put some channel in between to put some guard band. It will help you as well. Other than that, this is unlicensed band. Keep in mind, in unlicensed band, interference is very directional. So there's multiple ways you can improve your performance in the unlicensed band, such as using a high performance antenna, which it will make the slope much. It will press your slope, so make the signal more concentrate. You can also using some natural environment, like if you're on the rooftop, you may using the rooftop to give you certain block for the signals you don't want to receive, or you purposely install the antenna or a radio in some of the using the like chimney or something to block certain interference from certain direction. Because keep in mind, interference is very directional. You can leverage those things to give you a better better performance. So that's just something we also recommend when you do the sub 6 point installation. Okay. Sagar, are you there? Any comment? Any additional you want to comment?
Hey, Alan. I think so. The main thing I would suggest is if you are using the same frequency, you would want to be spatially at least 5 to 10 feet away from your original source. This again, as you mentioned, depends on the type of antenna you have. If you have a high performance parabolic pencil beam kind of an antenna, the effects of uh, the proximity to the other radio reduces. But if you have more of a sector or like a wide 3 degree beam width, it may affect the radio itself. So it all depends, but at least the rule of thumb is it should at least be 5 to 10 feet away.
Mm-hmm. Okay, let's move to the second question. It's how big is the antenna? So generally speaking, we offer the antenna size from 1 foot to 6 foot. We have a distant notice sent out last year. We end of life for anything larger than 6 foot. It's not saying there's no such antenna available. It's just we very occasionally we receive an order for 8 foot or 10 foot dish. Almost all I would say 99% of the orders we have is 6 foot and below. And we have antenna for both Sub 6 and also for licensed microwave. So generally speaking, is and our antenna manufacturer come from CommScope and Radio Wave. They're the two antenna manufacturer we're using. So if you use the link planner, you will be able to see what antenna we offer. If you do have project require say larger antenna, 8 or 10 foot, you can talk with our RSM, and we will be able to we can still buy from those suppliers and resell them. It's just we don't have a part number exist right now. We only carry those, basically majority of the things we already sell. So that is about the question for antenna. Okay. All right. So this is the second. I don't have any other questions right now under the question box. So if you do have any question, as I said, it doesn't matter it's licensed or Sub 6. Any questions regarding the product, installation, feature functions, pricing, anything, we're open here. So maybe we can start. I mean, while we're waiting, let me explore a few things. Maybe we can ask Sagar can help us. So this is the Sub 6. We have 550, 450, EPMP 4300, and PTP 670. So Sagar, when we have so many different products, what do you see? This product will, like the general guidance, which product I should choose based on my application. You may want to give, if you can give some examples saying if in this case you want to go with this radio, some like rule of thumb, it'll be help.
Right. That makes sense. Thanks, Alan, for the question. So we'll start with the PTP 550. So that's mainly a dual band radio, which means inside the radio you have two separate radios, and both the radios operate independent to each other. So this 550 is based on the 802.11 AC chipset that we have. So this is a really low cost or affordable product, which is primarily used for high capacity. Next, we'll focus on PTP 670. So PTP 670 is the best product in our product portfolio. It has a lot of key features, including security features, and it can be configured as point-to-point or point-to-multipoint. The maximum capacity for 670 is 450 Mbps. So these two are our primary products that we have. One is for speed and one is for utility and durability. Our PTP 700 is a military grade product that we have. So won't go too much into the specifics. Next, we have the PTP 450. So the 450B is really useful for customers who are already using 450 as their point-to-multipoint point solution. So the advantage of that is there's no need to relearn the chipset or the UI or the installation. A lot of the parameters are the same. So having that flexibility, and 450B does about 600 Mbps. So if that satisfies your capacity need, 450B is a really good solution for that. The 450B high gain 25 dBi dish that we have, which is based on the same platform, and we have the PTP 450i. So this one is based on the 450i, which is again based on the PMP platform. This one has auxiliary you can use to connect to a camera or outdoor. Next, we come down to our EPM platform, the FORCE 300-9. So it's a 19 90 dBi and antenna gain. It's really good for short distance point to point, be 3 miles, 5 miles. It's a good distance for this one. A slightly longer distance, for maybe 5 to 7 miles, we have the ACMB 4300-25. The maximum capacity for the 4300-25 and 4300-90 600 Mbps. Last but not least, we have our EPMP bridge in a box. This is based on a 802.11n chipset. So the max capacity is about 200 Mbps.
Okay,
So this
thank
gives
you,
you
Sagar.
a variety. Yeah.
All right, great. So there is some audio. I heard the audio is not very clear. There is, but I think we can we put some notes in the forum, so you can also see. I mean, they're pretty. If you go to our web page, you can also see the brief highlight for each product, and you can use that one as a guidance as well. Let's go back to the question box we have here. There is a question about the dual pole antenna and single pole antenna, and also so basically when we should using which one, and also what's a guidance for high performance antenna, standard performance antenna. So generally speaking, I mean, the people using a dual pole is you're using another vertical. Like for our PTP 670, we do the MIMO, so it's always we prefer you go with dual pole, because if you do a single pole, you literally lost one half of the capacity. Similar thing for 550, it's always there. And for licensed microwave, it really depends on your licensing. If you want to run XPIC, the same channel with cross polarization, you kind of go with dual pole. It's give you better capacity. If you go with a single pole, they have to do different channels because you can't run in the same channel with a dual pole. So generally speaking, for some is mandatory required by the radio. We do need a dual pole dish all the time. Otherwise, you lost your capacity. That's for the Cyber 6. For licenses, ready by licensing you get. That is kind of like between dual pole and single pole. The second question is regarding high performance and standard performance. I mean, it's a trade-off, right? The pricing, the price for high gain or not high gain, high performance antenna, not necessarily mean high gain. You need balance the return. High performance antenna really means it's high. Basically, the slope will be cut further. So in the licensed micro, we have class 2, class 3, depends on which in the SC and the FCC. In the SC, there is there is class 2, class 3, class 4. The higher the class, the better the antenna. It's more about beam, the shape, the spectrum. If you look at the mask, the spectrum mask, the slope will be cut further, so you'll be more focused. The energy is more focused. You can also get rid of the interference. The benefit for that is frequency reuse. Actually, if you own people own a block of spectrum, then using the high gain antenna, they can maximize their frequency reuse. If you're using a standard antenna, because it cannot get rid of certain interference on the side lobe, so their frequency reuse is not as great as high performance antenna. There's no there's no antenna gain difference, but there is, because of this slope thing, there is a big cost difference. So it's really about your where you deploy this, and do you really need it. In general speaking, I think if you deploy a link in a high density area, what I mean is the spectrum is very dense. If we talk about the US, 6 gigahertz and 11 gigahertz, they are I mean, most of the spectrum is pretty congested. So if you deploy a link there, you may have to go to a high performance antenna in order to be licensed. So that is where you have to go. But if you're in the rural area or not that dense for the spectrum, standard antenna should be quite enough. If I look at our sales record, I would say probably 80-90% of our sales go with the standard performance antenna. The very high performance antenna, we don't like a VHP, those kind of things, UHP line, we don't sell much. We only sell those where customer cannot get a license for. So that is where the difference. Okay, that is one question for the antenna. Next question I have is a question about 800. So on the 800 series, there is a high power version. What would be the operation max range for a throughput of 1 gig? So I think there is. So first, let's clarify a few things. From Cambium, we really don't call high power and radio or standard power radio. In the 800, we only have a radio on every frequency, and they're all people call lower 11 gigahertz radio high power because they have a standard power version. In Cambium, we don't do that. Literally, all the lower frequency, we always go high power. On 820, same thing. If you go with 820C, we just have one. But on the 6 gigahertz and 11 gigahertz, they're higher power. We do have a specific high gain, high power radio on the 820C HP line. That one, the radio supports 35 dBm on the transfer power, which is extremely higher. So the maximum range, the question is really about what is the maximum range. It's a little bit tricky, depends on which frequency you're using, and also more importantly, it's about the antenna size. The link planner is the best place you can go. Literally, you choose your radio. We put all the radio in the link planner. You choose your antenna size. You also need to determine what is the link availability you're looking for. 4.9 versus 5.9, there's a big difference on range as well. With high gain dish, not high gain dish, sorry, with high power radio, you can shoot for much longer distance. Like for our customer, typically people go with HP radio if they shoot for 20 or 30 miles or 40, 50 kilometers. They go with high HP power radio. And also we have an indoor version as well. So there's different one. The HPC 820C HP is the outdoor version, and the RFU A has two variations as well. RFU AE, and RFU AXP. They're two different power, different versions as well. They're all suitable for long range. And you basically go with link planner. You can choose different radios to see what's a range you can get. Okay. Next question I have is about 450. So the question is, what is the difference between 450B and 450B high gain? Is this just about the antenna, or there's something else? Sagar, you want to cover this one?
Yeah, I can cover this one. So the main difference between 450B and 450I is two main things.
No, 450B HP, high gain.
Oh, high gain. I see. Yeah, the main difference is only the antenna.
Right. So do you know what is the high gain antenna again? Is 23 or 25, something like that? What is the PTP 450B?
I think it's 17 dBi.
17?
Yeah, the mid gain one. Yeah.
Okay, so the delta is about 7 dB for the antenna part.
Yep. So the distance you can go twice as, or maybe 4 times as far.
Yes, 6 dB. Every 6 dB, you double your distance. So if you have both sides on a P2P application, so this will 4 times your distance if nothing else change. If in the PMP configuration, this will double the distance because there is 7 dB difference there. Okay. All right. So we don't have any other questions under the box. I'm gonna talk about the license microwave here. While if you have any questions, please put it into the under the question box. So you can see the license microwave. We have 2 groups: the all outdoor and split mount. Generally speaking, if you're IP centric, go with all outdoor because you don't need many interface. You should go with. We recommend go with all outdoor. Unless you really have a concern to replace radios, you don't want to climb towers, you want to go with split mount or all indoor. So that is the case like in the public safety or utility customers, oil and gas. Many of them, they still go with split mount simply because not only because they want to change the equipment easily indoor, but also because some of them, they still carry the TDM like T1 or E1, so they want a more interface. So, our recommendation, rule of thumb is if you're IP centric, go with full outdoor. If you're not, you still have TDM, other things, you go with split mount. For full outdoor, there is, 5 radio here, pretty much by capacity. If you're under 500 meg, go with S. If you're 1 gig or 1 gig, go with A20C because it's dual core, and we have a HP version and the standard version. If you need a 10 gig, 2.5 gig or 10 gig, basically, that is the E band. We have A20E and 850E. 850 is a 10 gig radio. A20E is a 2.5 gig radio. They all have SSP interface, SSP plus interface, so you can run a single fiber cable. On split mount side, you can see is we have 2 group. One is A20G and A20F. If you do a simple link, 1 plus O, 2 plus O, go with A20G. The A20F is really a aggregation radio, meaning is because we have a single modem, we can shoot for 3 paths up to 5 carriers. So if you have an aggregation site, you shoot for different direction, and that is where you should go with A20F. The A20F single modem support 5 carriers, so which means it's 2.5 gig maximum capacity. A20G support 2 carriers, so it's 1 gig. So in general speaking, if you do a single link, A20G, do a 2 plus O link, A20G. If you do a 1 plus O east and west, A20G. If you do aggregation, multiple direction, more capacity, A20F. That's kind of like what I distinguish between the 2. And A20G, we have RFUC and RFUA. RFUA is high power indoor. So, that's pretty clear. If you want to go with indoor, RFUA. A20F, we have 4 different RF head. RFUD and RFUDHP, basically, think about them, they collect A20C and A20CHP. They're dual core. So they can single radio can support 2 carriers. And RFUS is like A20S, single core and standard power. And RFUE is like E band. It's more like the A20E actually, is the 2.5 gig radio. So that is your choice. If you go with A20F, depends on which direction you want to shoot, because we shoot for 3 paths, 5 carriers. And if you want to go with aggregation, then RFUD, single carrier, RFUS. Want to go with E band for high capacity, RFUE. That is where you should go with A20F. Okay, that's kind of like rule of thumb. Of course, everything, the licensed and unlicensed, they're all in link planner, and you can choose whichever one, whichever radio, and play around. Choose the antenna size, choose the frequency, choose different radio type, and see how this fits your requirement. Okay, Let's go back, take a look again. We don't have any further questions under the box. So I guess if there's no more questions, final call for any questions. If no questions, we're gonna end for today's webinar. So Olivia, we're back to you. I think there's no more questions.
All right, thanks, Alan and Sagar. We'll have a recording of this webinar posted to the Cambium Network's YouTube channel and our community. Thank you for joining and have a good day.